So when we're discussing solutions, sometimes it's more important to focus on the parts of the solution that are actually changing and kind of weed out the parts that are just, you could think of it as watching the reaction happen. And so for that, we have net ionic equations. So I'm just going to show you an example of this, a complete equation of, say, the reaction between lead nitrate, specifically lead 2 nitrate, and potassium iodide. Those guys are going to react to form the soluble potassium nitrate and the insoluble, according to the solubility rules, and very vibrant yellow, lead 2 iodide. Now, the first thing that you can do is you can either balance first and then cancel things out, or you can cancel things out and then balance. It's totally up to you. I'm going to go ahead and balance it first because this one's a pretty simple balance. Let's see, we need 2 of these guys, which means we need two of these guys. Okay, so now we are balanced. And in writing a net ionic equation, the first kind of real step is to separate or ionize all of the ionic compounds that are soluble, and don't separate anything that is not soluble. So if something is classified as a solid, a liquid, or a gas, you do not ionize it. If it's classified as aqueous and it's ionic, you do ionize it. And to be able to tell whether or not it is or not, you look at your solubility rules. So I can see that lead nitrate, that is a soluble compound because nitrates are soluble. Potassium iodide is because group 1 metals are soluble. Potassium nitrate is very, very soluble. And then lead iodide, actually, if you look at your solubility rules, you see that most halogens are soluble except the ones that contain silver, mercury, or lead. So I'm going to ionize everything except my lead 2 iodide. So that means I'm going to have 1 lead ion. That's supposed to be a 2. Oh, that's being stubborn. Hang on, let me erase that and fix it. Lead 2. I'm going to have 2 nitrates. I'm going to have 2 potassium ions. And I will also have 2 iodide ions. And on the product side, I know that my potassium nitrate is soluble, so I have 2 of them. So I'll have 2 potassiums and 2 nitrates. And then finally, because my lead iodide is not soluble, I'm not going to ionize it. I'm going to keep this guy together. So now I need to go through and cancel out everything that is a spectator ion. And the reason that they're called spectator ions is because these ions don't actually change in the chemical reaction at all. They just kind of spectate. They sit there and they watch the other guys react. So if something went from the reactant side to the product side without changing its charge or its formula or anything, then we cross it out. And so I'm going to look at each one. I see my lead right here. It's part of a compound over here. So it did change, so I will not cross it out. Over here, I've got 2 nitrates, ions, and over here I have 2 nitrate ions that look the exact same. So that means they are spectator ions, and I will cross them out. Now moving on to my 2 potassiums on the reactant side, 2 potassiums on the product side. The potassiums did not change. They are ions on both sides, so cross them out. Then finally, I have my 2 iodide ions. And on the reactant side, they are separate and floating around in solution. And on the product side, they are actually part of a compound. So I am not going to ionize those. So my net ionic equation is going to be the lead ion plus the 2 iodide ions, giving me the lead 2 iodide. And that is how you write a net ionic equation.